Hello, calculus students. All right, so we are in section 2.1, and we just talked about definition of limits. Our last set of notes were focused on one-sided limits, and I'm going to go ahead and give you some practice on this, give you some demonstrations on how this is applied. In our OneNote, as you can see on my left side here, we have a 2.1 lesson check, we have 2.1 evaluating limits, and then 2.1 one-sided limits. This is the worksheet that I'm going to focus on. Okay, so in this worksheet, we have a massive piecewise function with many rows to this piecewise function, and this is the definition of it, and this is the visual of the piecewise function. So let's go ahead and talk about one-sided limits and apply it to the graph itself, and then I'll show you the function definition of how it's also applied. So for number one, we have the limit as x approaches 1 from the right-hand side. So this is a little plus sign. It means the right-hand side of 1. Here is x equal to 1. And if I'm looking on the right side of 1, and as I approach 1 from the right, my y values are approaching, looks like a 2. So that's going to be a 2 right here. Now, if I look at the left side of 1, that's this right here, the left side of 1. Let's see, if I go to the left side of 1, here are my y values, and that's approaching a y value of a 2. Oh, excuse me, a 1, y value of a 1. So then I have this limit as x approaches 1. So this is defining the limit itself. The first two, the right side, the left side are individual, and now we can evaluate what is the left side saying, what is the right side saying, and they're not saying that they're converging to the same y value. So that tells us that this limit does not exist. The limit does not exist. There's not a single y value that it's converging to. Then the next part is f of 1. That means the exact value. If I plug in a 1, looks like it's going to be shaded right up here. That's going to be a 2. And then, of course, does f of 1 equal that limit? And of course, no, the limit doesn't exist. So that would definitely be a no. Now, how do you apply this in terms of the function notation, not having to graph it? Well, let's see here. If x approaches 1 from the right-hand side. So I'm looking at my domain, and I see here's the right side of 1. That's the x is greater than 1. So that means I'm going to go to my y values. I'm going to plug a 1 in, and if I do that, I'm going to get a 2, a y value of a 2. And then this is the left side of 1. This is less than 1. So that's the left side of 1. And I'm going to use that y value. There's no x to plug in. Otherwise, I tell you to plug it in, even though it doesn't say equal to 1. But the y value is 1. And there you can see that, okay, the limit to the right side of 1 is 2. The left side of 1 is 1. All right, let's check out the x approaches 2. And here's my definition of a limit from the right-hand side. So here's 2. So the right side of 2 looks like this right here. And my y values are approaching 0. Left side of 2. Well, just right on top there, left side of 2 is approaching a y value of 0. So now I'm asking for the whole limit. The limit is x approaches 2 overall. Well, because the right side is 0 and the left side of 2 is approaching 0, then that means the limit does exist, and oops, it does exist, and that means that the y value is a 0. So what is the exact value at f of 2? The exact value, not when it approaches exactly. Now, I don't have an overemphasized dot like I do on f of 1, or even like f of 3, right? So I don't see that big old dot, but it's there. I mean, I don't have to overemphasize it like I did in the other ones, and that is going to be a 0. So what does this tell me? Does f of 2 equal that limit? Yeah, it does. It does. So yes. All right, let's keep going with the next f of 3. The limit as x approaches 3 from the right-hand side. So I'll put a 3 right here. And let me just go through and maybe not have to do the highlighter, but right side of 3. If I look at the right side of 3, and as I approach it, Looks like it's going to be a y value of 2. And then the left side of 3, if I go to the left side of 3, that's going to be a y value of 2 as well. So the limit as x approaches 3 overall would be 2. The right side is 2, the left side is 2, so the whole limit itself is 2. Now how about f of 3, the exact value, not a limit, but if I plug a 3 in, what's my y value? And that's going to be indicated by this right here. That's where it's shaded in. That's the exact value. That's going to be, looks like it's going to be a 1 right there. Okay, so does f of 3 equal that limit? Well, no, of course not. It doesn't. The limit is 2 and f of 3 is 1, so that's a no. Okay, let's take a look at 4 as we approach 4. Okay, well, this one doesn't have an overemphasized dot like I did in the other ones, but it doesn't really matter. They're all a bunch of little dots. If I look to the right side of 4, it looks like it's going to be right. It's going to be a 1. The left side of 4 is also going to be a y value of 1. It looks like f, but the whole limit is going to be 1, and f of 4 will be 1 as well. So this is a 1, a 1. The limit itself, the whole limit is 1 because these two are equal to each other. So therefore, that's a 1. F of 4, that is also a 1. Again, it's not an overemphasized dot, but it is going to be a 1. And of course, this is yes. Okay, last, looking at 5, the x is 5. So just taking a look at the image of it. Okay, so from the right side of 5, it's way up here. That's going to be what, 3? And the left side of 5, it's going to go to 0. And that limit is not going to exist or not connecting. So let me just go down here. That tells me this limit does not exist. Does not exist. F of 5, where is it shaded? It looks like it's shaded right here. That's going to be right here, right here. It's going to be 0. So of course this is a no. Okay, so you can use the definition of the function to find all these values if you want to plug them into your y values, and you'll get the same result. Your assignments from this, if I go to 2.1 assignment, I have your part 1 that was due on will be due in next class period, which is Thursday, and then part 2 you can work on these following problems right here, 31 through 36. And then 37 and the ones down below. Very similar to what I just demonstrated to you guys. If you have any questions, feel free to email.